and salvage things that are busted. That's what we do well in very negative situations. I do not care which stack, okay? As long as it's client side, I'm happy. So if it's Ruby with a lot of Angular or it's Python with a lot of Backbone, I don't care. That's my thing. That's where I'm coming from. Again, the demographics for TypeScript in general usually is enterprise software devs. Developers who are at least on 2-man or more teams, or 2 women or more teams, right? You have multiple developers in the same code base, okay? Not one developer on 5 projects. Enterprise software developers have large code bases. There's also game developers. Game developers who are doing a lot of data intensive work tend to like TypeScript because it allows them to do HTML5 game development with some strong typing, right? And a lot of their engines that need, really good compiler help when they're doing a lot of math and stuff, it helps. So they like that. Even though it only has 1 number type. So what is TypeScript? What's the value? Well, it has strong typing. Okay, so JavaScript does not have strong typing. Everything is a variant or some weird version of null and undefined. In TypeScript, you actually have types, okay? Including your own types. We'll get to that. Number 1, 2 has classes, okay? Any JavaScript language that has, is a transpiled language means it's transformed into JavaScript. Is going to have classes because that's what most people who start off building these things feel like JavaScript's missing, right? Now it's in ECMA, okay? TypeScript is really big on ECMA. So if you're curious as to what's the point of it? Well, classes and all this stuff follows ECMAScript to the T. They're very strict about it. It has modules and asynchronous modules. What that means is that you can support both modules, like the ECMA way. You can define a form of namespaces. You can organize your code base in modules. It doesn't have to map up to files. This can all be in a single file. It also has asynchronous modules, which is utilized for now either CommonJS or AMD export modules, okay? It's not really CommonJS per se. They have exports, but it's a little weird. And integration. It integrates with tools. It integrates with existing JavaScript libraries. The reason that TypeScript has got a nice sweet spot is that the .NET developers who typically don't enjoy JavaScript can write TypeScript and even little bits of it to integrate with their front end in their tool, Visual Studio on their PC, and it works very well. Those of us who are doing larger projects can integrate strongly typed languages such as TypeScript with loosely typed ones such as jQuery, Backbone, Angular, whatever else by simple interfaces, okay? And finally, compiling. The whole point of strong typing and modules and all this stuff is having a compiler that says, hey, I just want to let you know you did something wrong. So it's a step above JS hinting and JS linting, okay? We have a compiler that allows us to know that, hey, we're doing things right, we're optimizing certain ways of coding things, we're generating the type of JavaScript that you want, okay? Good compiler, really good, or transpiler, whatever you want to call it. So why TypeScript? Well, first, before I even get to that on my slide, this guy right here, Jesse Warden, TypeScript. It's the easiest way. So if you go down here, I wrote this article a while ago, but the guy who invented TypeScript is Anders Hejlsberg. This guy invented Turbo Pascal, Delphi, and C#. Okay, he invented C#. So, or one of the people involved, and he doesn't have a beard, which makes him very unique as a language developer. One of the most popular languages in the world, used for Unity 3D, used for .NET, used for just about everything. C# is the most wonderful language that people love, and this guy said, we're gonna make a better JavaScript. So that's right there. That's the validation. Okay. So beyond that, why would you use it? Well, it's strongly typed. The compiler helps you with immutable data types. So numbers, are numbers. Now you're saying, well, Jesse, we can pass whatever we want in JavaScript functions. Not with TypeScript. If you define those types, you have a nice, strong API on those classes. Whether you're doing simple function calls or you're doing model view controller frameworks like Backbone and Angular, and you have the models that have specific calls, even in Backbone, which allows you to have configurable objects. You can define those value objects as types, and the compiler will help you verify that you wired up everything well before you even attempt to run it and test it, right? Before you even run your unit tests. That's the strong type. This has nothing to do with your type. So someone once asked me in an interview, he said, why use TypeScript when you have CoffeeScript? I mean, how many types are there really in JavaScript? That completely misses the point of data modeling your data. As a lot of these applications go from the server to the front end, right? And you have 90% of your code running in the cloud on some middle tier like Python or whatever else, and you now run 90% of that code on the client, you're using a lot of the data objects. You're building your own CRUD layer. You're building your own data access layer, whatever else, right? Not core data level, but you're getting pretty close. The apps are getting that size nowadays. So you're using types. You're using a person VO, not just some JSON object, okay? TypeScript can allow you to describe those objects, put them in an API, and you have a nice, wonderful, strongly typed API, and the compiler can help you if they don't wire up right? So JavaScript can't do that. TypeScript can. Number 2, the compiler helps with everything I just said. More focused unit tests. So of course, from the ivory tower perspective, of course you should write unit tests. You should write good, valid unit tests. You should write unit tests that, work with testable code. You should write testable code so your unit tests are nice and actually can test them, right? But the point is that most people don't write unit tests. This is the way it works. It's very difficult to sell to a client. People who get it. The rest are like, why do you want me to write code twice and extending my development time for this supposed, lack of bugs? I'm not buying it. So it is what it is. So if you're going to write unit tests, you can at least write more focused ones. The compiler can help you with that. If you're not going to write unit tests, cool. You now have a compiler to help you with simple errors. Fantastic. This in addition to the JSLin, okay? It's not myopic as it sounds. I'm really trying to be positive. Number 3, it uses ECMA 6, and, well, I make up 7 and 8, but really ECMA 6 is very strict, ECMA 5, okay? You can use that ECMA 6 today. The code that works yesterday is going to work yesterday and today and tomorrow. So anything you write in TypeScript is going to work. It's going to work for older browsers. It's going to work for newer browsers. It generates JavaScript. So you don't write TypeScript and run it in a browser. There's no source mapping. I mean, you can, but there's no source mapping to your actual TypeScript. It's writing JavaScript. So it's assumed that you know JavaScript. You just want to utilize TypeScript for its features, okay? Number 4, compiler helps with misspellings. So simple misspellings with these contractual obligations it helps with, which is pretty cool. Number 5, obviously classes, duh. But classes from a inheritance perspective, from a super class and subclass perspective, and from an overloading perspective versus overwriting. Fantastic. Awesome stuff. Packages, or namespaces. They're not really namespaces. If you look at the way that they're implemented, it's very confusing. They're getting better, but it's not unless you're using Visual Studio with local modules, it's not as simple as something like Java or Python, where you can import the module, have a reference to it, and utilize, a class from that particular thing or a function. It's not that simple, very frustrating, but it's a way for them to, sell Windows and Visual Studio. I get it. If you're on a Mac, it's so sad. Inheritance that works, I already talked about that. Retains the functional aspect of JavaScript. So I was so excited to see a to-do MVCS. If you don't know, any framework, any awesome, large, hyped library is put on the site called To-Do MVC. And what it is it's a way for you to see how to do a simple to-do app in a JavaScript framework. So you can see how they use Backbone to do the same app, how they do Ember to do the same app, Angular, Knockout, yada, yada. And you can compare and contrast the implementation, right? That helps you learn from sample code and compare and contrast the framework. The problem is that the way it was written with TypeScript is extremely functional. It's like a JavaScript developer said, I'm going to borrow some of the cool things in TypeScript. Cool, you got the compiler aspect, you integrated with existing libraries, but it's not written like a C# or a Java developer would tend to write code, right? So it's definitely not something to judge, okay? So if you see this presentation, immediately go to todomvcs.com and then look at the example codes. Do not judge it based on that. The author is very functional and likes promises and chaining and things like that, okay? You don't have to write it like that. It strictly follows ECMA. They are very strict on the forums answering posts about only features and bugs and such they'll implement as long as they follow ECMA. So even though it's Microsoft and you can say what you want about privatization, they are really, really strict about following ECMA, which is cool and uncool. It's cool from people respecting it, uncool because I want all this awesome stuff and I don't really care if it follows standard because it's not JavaScript. So I don't care. So why, again, also it integrates with JavaScript with optional strong typing. So you can do a little bit of TypeScript or a lot. You can integrate with languages that aren't typed and you just won't get type safety and that's okay, but your TypeScript will work. Or you can wrap a contract that's strongly typed around it, such as jQuery overrides with their function that does multiple values, right? From an override perspective language that supports those things like Java. And the strong typing is optional. So if you don't want to strongly type strings or you just want to strongly type anything to any or don't want to strongly type at all, that's fine. So it supports modules. This is why I love it, because you can do packages and it's built into the language. It exports to require.js. So anybody who does classes and minimal amounts of dependency injection with some of the weird configuration variables that require does, you can use modules. Fantastic. Now I use AMD. I know a lot of people like CommonJS. It supports both. It also exports to object prototypes. So here is the difference. There is a interview question that's really annoying, but people love to ask it to challenge your knowledge of programming. Because if you don't know this, you probably don't know MVC, you probably don't know OOP, and you probably can't really accomplish anything in the company that they're hiring for. I'm being sarcastic. It exports to object prototype for the performance values, right? So there's this big thing, like the guy who created JavaScript and JSON and Ajax is like, well, I like closure-based classes. So I don't want to use, prototype. I want to do objects and return functions and, put in the module pattern and call it a day. There's others who are like, yeah, but object prototype is very fast. You can create multiple instances and it's optimized. Not really. So here's the key. The only thing you need to know about the object prototype optimization is that they do not put properties or getter setters or whatever on object prototype. It's assumed that everything is an instance based. Now, if you know anything about object prototype, is that every single instance of the object prototype class will share the same value on the prototype until that value is changed. Then they each get their own unique instance. And there's no real polymorphism because if you change it, it doesn't change for, sub-instances as well, right? So TypeScript's like, look, we'll put methods on there. Cool. We will treat an object class just like a method. It's a normal prototype-based class with some fixes for super inheritance and overloading. Fantastic. But for properties, no, they're all instance-based. There's no such thing as sharing properties on prototype, okay? So optimal class performance. That's the whole point of exporting. Strong typing. So let's talk about strong typing. Beyond the types of you creating, what is the strong types? It is any. So you can do nothing and it's assumed to be any, but if you type any, it's known to be any. Thus, when you're developing APIs, you can accept any type. Number 2 is number. There is no int, there is no float, no unsigned blah blah blah, it's just number. The point is that it's assumed to be a float, okay? It is Boolean. Notice they're all lowercase. And string. And enum, I believe there's date, but we don't care about those. These are the ones that are a big deal. Enum is a huge topic unto itself, which is great. If you've ever tried to emulate enums, even with a good editor such as Sublime or WebStorm IntelliJ, it's awful. The enums just get really nasty. So the fact that they provide it is wonderful. They have a lot of other ones that are small and minor, but those are the big ones. So let's talk about some of the data types. I'm going to show you some examples here. So as you can see, this guy right here is X is any, okay? Y is the same thing. Just because it doesn't have typed, it means it's the same thing, okay? So B and A have no values. It's the same thing as casting them as any, because they're objects, right? They're object with the properties of the object. Notice that this function X, F with X, or my function, X is cast as any. There is no type here. There's no string. It's just you can make X whatever you want, and the console will log it up to the console. Also note that log and debug and everything else in console takes any as well, right? So you can create an interface on top of that to say any. The point is that these are synonymous, but this is explicit. It means you meant for it to be any. So if you pass a string and a number, it's okay. Versus, I didn't mean for you to pass me a string. Well, then cast it as a number or whatever else you're casting, okay? Number, same thing. You can cast a number explicitly. This is also treated as a number. Notice I didn't do it for Y. Same thing with floats or decimals. And same thing with strings that are fixed to that, okay? I'm sorry, property the number, sorry. Boolean, same thing. They too have a cast. It's implied that these are both Booleans, okay? You're not going to cast it, you're not going to type Boolean, but they are Booleans. And string, same. String gets a little tricky, but it supports the double quote ones, the single quote ones. And if you're getting a particular character using the string method, they're all cast as strings. It's just this one is explicit and intentional, and the compiler will help you. If you do not do that, sometimes the compiler is smart at guessing, sometimes not, okay? They do have type inference, and this is what I was talking about, the compiler guessing. Notice how last name is actually known, or the return value, right? Whatever evaluates inside this parentheses, it's known to be a string. So it's expected that this function is going to return a string because the two values that you're concatenating here or adding together are a string, okay? So the compiler has some forms of type inference. Got it? Notice we didn't type string here as this, nor did we type the return value to string, right? You could do that if you wanted to. Got it? All right, now let's talk about ambience. I keep talking about integration, and you can do strongly typed integration. What does that mean? It merely means that global variables can be defined like so. You say, hey, declare var document. Trust me, it's a global, it's already there, it's in every browser. Same with window. So you can do this and the compiler will say, okay, cool, versus the compiler going, I don't know what document it is. You didn't define it. Well, I know because it's global. It's by the browser, right? That's how you declare it. Same thing with jQuery, right? jQuery and others have to be shimmed usually on require.js to know that they're already predefined, either from some library or somebody else who brought it in internally. TypeScript can do the same thing, so you can declare, you already have variables there. Please utilize them. I've declared them. Compiler, ignore them unless I provide additional interface information, right? So that's the basics of those guys. That's all you need to know about strong typing. Classes. Yes, it's a real class. It exports to a mishmash of prototypes and closures. All kinds of nasty stuff. Now here's the key. It is formatted nicely, and it is, for the most part, readable, okay? So if you're into prototypes and everything else, you can go take a look at TypeScript's Playground and how it generates, okay? And I can show you right now, actually, because I can. So if you go to Playground on TypeScript.org, it will generate left and right. So you can look at how it looks when you actually have a module, you have a class, and it generates. Notice that it has the module pattern, right? And it'll export it out. Now it defines it up top. Now this is tricky. You don't have to do that. You can just snag the internals and get rid of this and call it a day. They're doing that for module reasons. So if you compile your entire TypeScript into a single file, it'll work. The challenge becomes if you have multiple classes, you have varsanes declared twice. So it gets a little tricky. And I'll get to that. This is one of the frustrations that people have had. But the point is, it generates it. You notice that the function is a normal function. Your method is on there, right? You have your greet method. And it generates normal JavaScript. You can do the same thing with, if we show you the normal class, okay? So that class will go to a normal one. It's a little bit more readable, right? As the greeter. But notice that the greeting, even though it's a property, is not on the prototype. So we don't get that weird thing I was talking about where every single instance points to the same property until it changes it. And then it gets its own unique instance. Now, people who like prototype-based programming think that's awesome. For the rest of it, it's really confusing and it's not helpful. Usually when I create a class, I want an instance space. If I wanted a static variable, I would go greeter dot property equals some value, right? That's static. That way everywhere can have the same value. Once you set it to prototype, it's only static some of the times, right? Completely useless, not helpful, not good in object-based oriented programming. If you're a functional programmer, you don't even care about this stuff anyway. So TypeScript does it, has super, all that stuff, okay? It has inheritance. It allows you to call super-based classes. It has a super keyword, right? If you're an ActionScript developer, you're like, well, I've been doing that since 2001. Well, good for you. JavaScript developers and TypeScript now have it. Public, private, and static. So you can utilize public. You can utilize private, right? Now, is it really private? Of course not. It's a variant-based language. You can dig your way into even closures and hack your way in there. It's harder, but you can do it, right? They don't enforce any of this at runtime. This is all at compile time. Once your code is JavaScript, this is meaningless. All the private, and public, and static doesn't mean anything. And no, it doesn't have protected. I know, everyone's sad. I've already said super. All right. Now let's show you some class basics. I already showed you what it generates. Let's get a little more specific here. So you have a class called point, right? It has the class keyword. You can define a constructor. Constructor gets really deep. If you want some more details, go look at the TypeScript documentation or look at my blog post where I cover a variety of examples of how you can do that, okay? It's made for ActionScript developers, but it doesn't matter. Any language you come from, you'll be able to understand it, unless Perl, in which case you're really smart or really strange, one of the two. So notice how you can do public. It's defined there. It automatically sets those instance variables. That's one of the thing of saying public X. I know it's a strange syntax, but it follows the ECMA standard, so whatever. Notice we have a public length function, and you have a static property, right? So you can also do interfaces. So when I say classes, you can take an interface and apply it to an existing object and treat it as a class, right? So you have that whole programming by contract model that tends to work in Java and C#. It works just fine in TypeScript as well when you're doing JavaScript, right? Which is cool because sometimes the JavaScript you're dealing with is not yours. It's another library. So you can still get that contract and strong typing over top of it. Win. All right, so you'll notice, again, we have a point and point. We have a class point and we have a type point. What's the difference? This is saying P is of type point. This is a class constructor when we go new, okay? Notice the different colors because they have a TypeScript plugin for Sublime. This is awesome. This is helpful. And if you cast it to something else, the compiler would go, no. And it would help you before you even compile and run your code and unit test and all and blah, 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 blah. Cool stuff. Okay, so that's the class basics. Modules. So let's talk about modules. What are modules? Modules are just a way, usually in most languages, they're packages, namespaces, and modules are the same thing. Usually, like from the point of actually utilizing the language, they're the same thing. In JavaScript, they're a problem. There is no normal way to do modules. Everyone's created their own way of doing things. There's competing standards, AMD, CommonJS, the Node, CommonJS, blah, blah, blah. Right? Modules in TypeScript are really just the language defined in a module, and it could be a file or not, and it's either public or private, one of the two. Now, the difference is that when you generate this, most people who generate TypeScript in applications are going to use require, and they're going to do modules that are each in its own individual file. So every class is inside its own module, inside its own folder structure that matches, right? Very similar to Java or C#. But you don't have to. You can do local modules and put them all in the same file. Up to you. Okay? So local, public, and AMD.js. Really, it's all that really matters. I like AMD. Some people like CommonJS. That's the thing. So they're packages, okay? So let's show you some basics of the modules. If I go into the basic, I have a module that looks like this, right? So if I paste this into TypeScript, you can see that it will generate the define function, which if you're not familiar is part of require. You define classes or modules, and then you can then require them via the required JS library, and at runtime will asynchronously load them in the order that the dependencies are required. So if you have multiple classes that depend on each other, require will handle loading each one in the proper order for you and defining them correctly, right? Pretty normal features of most programming languages, Ruby, Python, ActionScript, Java, C#, whatever, except for JavaScript. Well, they utilize require to fix that. Pretty cool, huh? So you get all your classes loaded in, good to go, and you can instantiate them and call it a day. Pretty rad. Now you notice I have an export module, right? That means it's public. If I want to make it local, I do this, and it will be local. Now this defaults to the AMD compilation method. But if I were to just take all this stuff out and define it with just that, you'll notice there is no define. It's a normal module. It's assumed at this point that all your modules are going to be defined in a single file. In fact, you don't even need this varcom, but you could, right? It's doing the varcom for the export specific way, right? So it can do the whole export space modules. So that's the basic module. Let's show you some AMD versus local. Now again, I just showed you that. I'm going to show it again over here. AMD is really just asynchronous module definition. It's what most people in require do, but they also have the exports way of doing it as well, if you'll notice at the bottom. So it still does exports. It just depends on the compilation flag that you supply, okay? We don't really care about this. When you were using require, all you really care about is define, and you're good to go. Cool? Got it? Makes sense? You excited yet? Integration. Let's talk about integration. This is where most people go, okay, all these things look great, but I've got an existing code base, can't help it. I'm just going to have to play with TypeScript in my unit test and nowhere else in my source package. Not necessarily true. The integration is the whole point of ambient declarations. I just showed you how you do declare. You can say ambient, it's already declared, or it has these declarations already predefined. So when the compiler runs, it already knows what it's dealing with. It's not waiting for you to create a class and a module and export it. It assumes they're already there, and it's going to follow the interface and use that to judge how much compiler help it's going to give it or not. It's up to you, right? Which is great. You don't have to. You can say jQuery is dynamic and call it a day, right? And the compiler will not complain at all. You can use interfaces, like I said, to define those particular objects. You can even treat interfaces as classes rather than writing a class. You can say, well, look, there's an interface. I'm loading it from this existing code base, which kind of is a class, but not really. It's already predefined. So I can create the interface and say, look, this is our way to integrate with that with strong typing, because it could be a third-party library. It could be code that's 10 years old and you're not allowed to touch it because of technical debt, right? For whatever reason, TypeScript's got your back, okay? And again, if you're looking for type definitions, I got to show you this guy. If you go here, this guy has provided typed definitions that are pre-made for just about everything. So let's look at Angular, because that's the soup de jour everyone loves, okay? And you see the type definitions for just about anything. It has the declare Angular, right, as being a already predefined variable. It has the interface for that particular function with the inject. It has the module of ng already there, so you can do ng dot. It's already provided as a module. It's already there. All the methods have strong typing. Now you'll notice they even have types, right? The element is of a type of jQuery of elements, so they defined a lot of those for you. So the compiler will help you to make sure that you're passing in the correct thing for a particular bootstrap. And notice they do some form of method overloading here in the interface that you can provide a variety of different methods. So even though TypeScript doesn't support method overloading at runtime, the interfaces do, because again, there are methods that are overloaded, and that's how functional programming works. You can fake overloading by changing how you work based on what arguments are passed in, right? So the interfaces got your back, man. So again, everything's here. I mean, Angular, Backbone, blah, 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 the whole internet's here if it's written in JavaScript. That's integration. You can make those interfaces. Compiling. Let's talk about compiling. For the most part, you use the TypeScript compiler, or TSC, which you can install via Node, or you can install other ways. I install it via Node, npm, Node Package Manager. You pass in the file, and you pass in a command line comparator such as the module type, I like AMD. Done. That's it. It compiles your JavaScript. Or you can do what all the cool kids are doing nowadays using Grunt. So if I go in my Grunt file, you can see I have a TypeScript task, and it says, all right, here's my base directory and source. Anything that has the .ts file suffix, I want to compile and shove in the build directory. The module type is AMD, and the target is ECMAScript file. Now you can play with this. You want to do 3 or 5. They have some other values, but the point is like I want to target 5. 5 will work, it's fine. There's some minor features that act differently based on whether you do 3 or 5. Nobody cares, it's good enough, works, unless you're one of those functional kids like, no, I must act like this and have this. You can also set up a watch, so as you're typing TypeScript, it'll constantly compile, okay? So as you save your file, as you create a new file, whatever, type Node and Grunt will watch your files for changes, very similar to SAS if you're used with that or less, okay? And don't worry about the open, all we care about is watch. So to watch that. So if you want to run this, where's my Grunt source file, my hello world, and I'm going to save it, okay? And we're going to look at what's it generated in build. There you go, JavaScript as a module, fantastic, okay? Now we're going to go to make it a greeter, hit save, notice it's going down here, everything's good, but we have a missing or problematic little creation here for this greeter. Notice how I pass a string to the constructor, but the constructor takes a message module, right? So the compiler will tell you if you don't type things correctly. It'll tell you where it failed. And again, this is the point of using TypeScript, is that if you misspell it or don't spell it correctly, it'll help you. Instance is a new message module.com.message. This is the only thing I don't like about the syntax, is that it's a little verbose for modules, and they have to be careful about changing it because it's not going to follow ECMAScript 6 modules definitions on how they're defined. So it's not really like a namespace that you can define locally, and it's not compiled. I'll show you what I mean in a minute. So we can say a string, not a VO, right? This message is actually a VO. If you look at the message class, it is just a VO. It is a class of message with a type of greeting, and it has a method internally to do with the instance variable rather than being a string. Now that I have my message instance, I can pass it into the constructor, which, notice you see how it's cast as a actual message type. When I hit save, the compiler will be happy, right? And then this is the example. I'm not even running my code or running unit tests or anything else. My Grunt task is just watching it as a code, right? I'm just running the normal TypeScript compiler. When you have, hundreds and hundreds of files, multiple developers with very strict API requirements, the compiler is invaluable. It's valuable, but it's like so valuable, it's like, oh my God, valuable, like invaluable, right? Clear as mud, Jesse, thanks. Notice I have an export a module and I export the class from that module to make it public, which means in another file, I can import it via the module definition and use it. Now, there's a way utilizing local modules where you can reference the path using 1, 2, 3, right? That way if you get rid of it, you just hit backspace. So 1, 2, 3. It'll reference local modules this way, and this is fine because it's assumed that all of those are going to go in a single code base. And that's okay, but the problem with this is that it doesn't really work with multiple files on multiple code bases. So if you have, hundreds and hundreds of files, and then you have a build task or compilation process that brings all these files together, right? A normal developer workflow for a large project. These are lame unless you're using Visual Studio. And most people don't do this. Most people are going to do export if they're going to code, raw TypeScript or JavaScript. Okay, so just something to be aware. You have this option, but it's expecting the IDE to manually find these things, and you're not going to type that. on a large project and, refactor it, not happening. You know what I mean? You want to have tools. And that's the other thing is we don't really have good refactoring tools from doing this stuff. IntelliJ is not really there yet for TypeScript. They have watchers set up, but not from the refactoring perspective. But it's getting there. Otherwise, buy a PC and use Visual Studio. And again, all this stuff will compile out down to normal JavaScript, right? And you can utilize it. It's from a required perspective. It's all prototypes, right? So it's optimized for that. Okay? And again, you'll notice that all this module stuff that I was writing is not in there. So all this import, the module up top. Let's take this out. All this stuff and all this stuff. If you look, it doesn't have any of that module definition. That is strictly for the compiler to know what module you're talking about. So when you actually compile down, it has nothing to do with the code generated. So TypeScript's smart. It can keep its language-specific stuff in there that is ECMAScript compatible, but it only compiles actually to usable JavaScript. And keep in mind, if you get tired of TypeScript, you don't want to use it anymore, your project's still written in JavaScript, so you can still use it, right? So you could also experiment on your unit tests. That's fine. A lot of the gateway people try to experiment with CoffeeScript is they like to test only CoffeeScript in their unit test suite. So all their unit tests are written in CoffeeScript, but the rest of their code base is written in JavaScript, right? And that works out pretty well because they have a nice test bed to test CoffeeScript. So they don't have to overly commit. You can do the same thing with TypeScript as well. You don't have to fully commit. Because once you set up a compiler in your source code, it gets, a little tricky. It's new developers why are we not coding JavaScript? I don't understand. So when you actually utilize it, notice all you have to do is require main, right? You're doing a normal thing. You have your main file, and you can require that main class, and you're done. So that's what's really great about the compilation. So I've showed you those things, local versus public. So if you have some spare time, I've written an article about, it's called TypeScript for Actions Developers. My name is Jesse Warding. Look it up on the internet. Here's the URL. I'll put it in the description. If you scroll down, I go over all the interesting features compared to ActionScript. And the reason that's important is ActionScript 1 and 2 were one of the first languages that followed ECMA 2, 3, and tried to pass the 4. After the ECMAScript 4 apocalypse happened, where they basically threw out 9% of all the stuff that language developers wanted, and they just kept it for the functional kids. There's a lot of things that were lost, but some of the cool features that are in there TypeScript has that are better are really great. So if you're familiar with ActionScript 2, which is really syntactic sugar on top of JavaScript, just like CoffeeScript, this will break down some of those core features that are really valuable from a pragmatic perspective. You can look in the docs, that's fine, but the docs are very computer science-ish, and this is very I'm trying to get things done today-ish, right? So constructors are really the really fun things. And then I talk about function literals, blah, 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 blah. So those are in there too. Why TypeScript? Beyond the fact that it was created by Anders Hojsberg, the guy who built C#, right? Delphi and Pascal. Well, it helps with multi-person, multi-developer, large code bases. That is the point of TypeScript. That strong typing helps it grow. So it's not just TypeScripting your normal, strings and numbers and booleans. No. It's your types, your classes have a nice contract and API that strongly typing compiler helps you, okay? You can use the future JavaScript today. So if you want to use ECMAScript today, 6 today, you can do so. You're not going to use let. You're not going to use yield. You're not going to use built-in language features that aren't there. It's strictly for the modules, the strong typing, the classes, the module definition. All that stuff's taken care of for you. You don't have to think about it, right? Inheritance. It's not a library. It's actually, code code for you. And the compiler, if they find a better way in the future, you can recompile your code. See, that's what's so cool about compilers. You don't have to change your code. As the compiler improves, your code can improve if you just recompile. Awesome. It integrates with JavaScript. So the big risk with CoffeeScript is CoffeeScript. It's not JavaScript until you actually compile it. TypeScript, via ambient decorations and interfaces, can integrate with anything. You don't have to write a lot of code. You can say it's dynamic and it's called today, right? 3 lines of code. You don't have to write the entire jQuery stuff unless you want to go download it from that GitHub link I showed you, and I'll also put it in the description. It outputs good, readable JavaScript. The JavaScript it outputs, you can use, you can read, and it's efficient. It's object.prototype, except for the properties, which we've already explained why. The bad? 1 year later, still not 1.0. Google Dart, as of today or last week, is 1.0. TypeScript, still not 1.0. And it's Microsoft, so what's going on? I think they got a lot of work. I don't really know. Namespaces. So I have some namespace issues, and so do a lot of other people, and they just are not helpful. I think this is to encourage you to buy and stick with Visual Studio.